Hello everyone, welcome to part 5 now of this midterm review. So let's go ahead and read the question real quick and learn about some trig functions. Okay, so here we have this scenario that is given to us and it tells us that, hey, we have some sort of shadow from this building and we know the angle that is given here. From the tip of the building all the way to its base is 63 degrees. That right here from the base to the tip is angle of elevation. Okay, we want to find the height x, so let me go ahead and write that there. But we know that from this point right here all the way to this tip, we can see that we know that it's 220 feet. So the question is, what is the height of this building? So whenever you see something like this, and we're going to assume this building is, done correctly. So this right here is a right angle with the ground. Now, if we know our right triangle trig, this should be hinting us that we should be using one of the trig functions, sine, cosine, or tangent. So ka toa, this one will be for sine, is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so let's see what we have. We are given, the angle, right, the theta, which is 63 degrees. This right here, from this angle, the horizontal will be my adjacent. We have opposite, which is x, so x is opposite. And this right here is my hypotenuse. So we're given 220 is my hypotenuse. Okay, so we have a theta, we have an opposite, and we have a hypotenuse. So which one of these three functions can we use? Sine, cosine, or tangent? Okay, hopefully you notice that when we have opposite and hypotenuse, we actually can use the function of sine. Okay, let me get the marker. So we have sine of the given angle, which is 63 degrees, is equal to the opposite, which we have no idea what it is, so we're going to call that x, which is what we want to find, over the hypotenuse, which is 220 feet. Now, it's just a matter of fact of solving for this, so we have to cross multiply, right? So x is equal to sine of 63 times 220. Okay, so go ahead and put this in your calculator. Make sure you are working with degrees in your calculator because we are given degrees here. So put that in your calculator. Keep in mind the decimals.com calculator works pretty good as long as you're in degrees. And you should have gotten x is equal to 196 feet, okay? Approximately, right? So this should be our solution. That is the height of this building. Okay, the next thing that we need to go ahead and be able to do is being able to find composition of inverse trig. Okay, what the heck does that mean? Well, that means when we have two functions and we're pretty much solving one within the other. Okay, what I want you to know is you need to know the restrictions of arc cosine. Remember, the restrictions of arc cosine are from quadrant 1 and quadrant 2. This is for arc cosine. And the restrictions for arc sine, and arc tangent are quadrant 1 and 4. 1 and 4. Okay, so those are good notes. Okay, so according to this, we have arc cosine, so we're going to be using this one. So let me go ahead and make my little triangle right over here. And we have something here. Now, keep in mind, we're working with arc cosine, so we're restricted to quadrant 1 and 2. 1 and 2. Keep in mind, this value right here is a negative 6 over 11. This is negative. This is a negative number. So what quadrant will it be in? Quadrant 1 or 2? Hopefully you said quadrant 2 because everything in quadrant 1 is positive. Everything in quadrant 1 is positive. Okay, so we're going to go ahead and draw this little triangle in quadrant 2, keep in mind that this right here has to be making the right angle right here at the x-axis, okay? So let's go ahead and fill it in. We have the following 6 over 11, 6 over 11. If we're working with cosine, we just saw, is my adjacent side over my hypotenuse. So my adjacent side is 6 and my hypotenuse is 11. Don't forget the negative. The negative is telling me that only the adjacent is negative. The hypotenuse is never negative, guys, because of the Pythagorean theorem, right? A squared plus b squared equals c squared. No matter what, our hypotenuse is always positive, okay? So we have this nice looking triangle right here. We are missing a side right here, the opposite side of this theta, but that's nothing to stress about because we can find it. How do we find the missing length of a right triangle? Hopefully you said the Pythagorean theorem, which is a squared plus b squared equals c squared, which is negative 6 squared plus b squared is equal to the hypotenuse, which is 11 squared. So we have 36 plus b squared equals 121. Okay, solving for b by subtracting 36 on both sides gives me b squared is equal to 121 minus 36 gives me an 85. And solving for b, right? Solving for b by doing the square root of b squared and the square root of 85 gives me b equal the square root of 85. Okay, so but this is not an answer. This is just the opposite length of the theta. So this is right here, square root of 85. Okay, now keep in mind all of this, the inside, all of this helped us draw this triangle. So if we do the arc sine of this triangle, we'll get the theta, this angle right here, right? So now we can solve sine of whatever that angle is. And sorry, I'm running out of space here. Is finding, so we need to go ahead and find sine of this triangle right here. What is sine of this triangle? Sine of theta. Keep in mind, sine is opposite over my hypotenuse. So my opposite side should be square root of 85 divided by my hypotenuse, which is 11. Okay, keep in mind, sine is positive in quadrant 2. Okay. Alrighty, these right here, guys, evaluating trig functions aren't that bad, but it is kind of tough when we don't know our unique triangles. So keep in mind, I'll go ahead and draw them right here for us. We have, well, I shouldn't draw it in a quadrant since it's the 30, 60, 90 triangle. So we have these unique triangles, right? The orientation does not matter as long as you have the angle corresponding to its length. So the 30, the 60, the 90 triangle. So the length that provides the 30 degrees is actually 1. The length that is associated with 60 degrees is square root of 3. And the length that is associated with 90 degrees is 2. This also works with our 45, 45, 90 triangle. Keep in mind, these are not to scale. So 45, 45, 90. And we can say that the length associated with 45 degrees is square root, I'm sorry, it's 1, sorry about that. It's 1. Same thing goes, since this is the same angle, the length is 1. And if I do the Pythagorean theorem, I get square root of 2. Okay, awesome. So let's go ahead and begin. Given this information, guys, we can actually find we can actually evaluate these. So sine of pi over 3. So if I was to go ahead and get my little axis, I would see that pi over 3, knowing that this is pi, this 180 would be sliced into 3 equal sections. So we can see that something around that area, and I should probably get a different marker. Okay, so we have something like this. So a lot of my students like to convert this to degrees. So pi over 3, what is that in degrees? So hopefully you said that is 60 degrees. And the length associated to 60 degrees, we just saw that, is square root of 3. And our hypotenuse is 2, and so that means my missing side is a 1. Okay, so if I do sine, which is, remember, sine is so ka doa. Okay, so sine is opposite over hypotenuse. So my opposite side is right here, and my hypotenuse is right here. So we would have square root of 3 over 2 is the answer, the ratio associated with sine of pi over 3. Okay, let's go ahead and try sine of 150. This one appears to be a little trickier, but it really isn't. 150 degrees, if we know this is 90, this is 180, this is 270, and right here is 360. Where is this angle located? 150, what quadrant is that located in? Hopefully you said a quadrant 2. So we have this right here. This is 150, right? From here to here is 150. Keep in mind, this is 180. So our reference angle right here is the difference between 180 and 150. So this right here is 30 degrees. So we have 30 degrees. This is 1, right? Because 30 degrees gives me the length of 1. So 30 degrees gives me the length of 1. I don't want to confuse you guys right here with my little extra number. Okay, so we have this so far. And my hypotenuse is 2. And my missing side is square root of 3. Keep in mind, this right here, cosine in quadrant 2 is negative. So I'm going to go ahead and have a negative square root of 3. Okay, so according to this, we're doing ka, which is my adjacent side, which is negative square root of 3, divided by my hypotenuse, which is 2. Okay, alrighty, let's go ahead and try the next ones. Tangent of 4 pi over 3. Okay. So let me go ahead and draw that real quick, and hopefully you guys can take over from here. We have that our pi over 3 will be split, our pi, right, which is 180 degrees, will be split into 3 equal sections. So here we have 1, here we have 2, and the third one is right at pi. So we have 3 slices, but we actually want 4 of those slices. So one more is 4 slices. So we have this angle from here to here. So according to our trig bow tie, that's telling me that I need to go ahead and have a triangle in quadrant 3, okay? And my reference angle will be the difference between pi and this 4 pi over 3. So the difference here would be just be a pi over 3, okay? And we know pi over 3 is 60 degrees. So this right here is 60 degrees. All we have to do now is fill in the angles that are missing. So we have that the angle associated with 60 is square root of 3. And that the hypotenuse will be 2. And the adjacent will be a 1. Keep in mind, which one of these will be negative? Keep in mind the negative 3 is below, the 1 is to the left, and the 2. Hopefully you saw that the negative 1 will be negative and the negative square root of 3 will be negative, because this is a negative height and this is a negative horizontal, right? So if we want tangent, tangent is opposite over my adjacent. That's going to go ahead and be opposites, negative square root of 3 over my adjacent, negative 1, which simplifies to square root of 3. Okay. Last but not least, we have sine of negative pi over 2. That's the same thing as saying what it is negative pi over 2 in degrees. Hopefully you said negative 90. So if I go ahead and find out where negative 90 is, I see that that is right over here, right on this coordinate. So what is this coordinate right here at 270? What is my x? What is my y? Hopefully you saw that the x is 0 and my y is negative 1. So here we know that sine is your vertical distance, so associate it with your y's, and cosines are your x's. So in this case, my y is negative 1. My answer is negative 1. Okay. Alrighty. Last but not least, what I want to go ahead and talk about is the functions of sine and cosine. Okay. So let me draw them real quick. When you are given a function with a basic sine and cosines, we have the following. Okay. I'm pretty sure you have a better explanation on your notebook, but a quick review, let's say cosine. Cosine starts at the max and it increases by pi's over 2's. So pi, 3 pi over 2, and 2 pi. Okay, so it starts in the max at its max height, which is 1, and it goes to the middle and follows this pattern. You can see it right now. It goes all the way to negative 1, then back to the midline, and back to the max. And it continues to the negative sides, and it follows this pattern. Hopefully yours does not look like thunderbolts like mine does. But this is cosine. Sine of x starts in the midline, and it follows the same idea as pi over 2. The same increases by the same. So pi over 2, pi, 3 pi over 2, and 2 pi. And its max is still 1, and its minimum is still negative 1. So it goes like this. So right here, middle, max, back to the middle, then to the minimum, then to the max. And the same thing goes for its negative. Okay, so it goes something like this. Of course, decimals, graphing calculators will definitely give you a better picture than I can. But the question here is asking which one of these is cosine, 3 cosine. So keep in mind cosine, we already know it's going to go ahead and start at its max when my degree is 0. But what does this transformation do to us? So if we remember our transformation of functions, when I have an a that is bigger than 1, I have a vertical stretch, right? Meaning instead of it being a max of 1, now it's going to be multiplied by 3. Now I got a max of 3. So automatically you should be thinking, which one of these can I get rid of if I just stretched it vertically? Well, consider B and C because those got shifted vertically and we don't want that. Okay. Now we're left with A and D. For these functions, only one of them is talking about cosine. Which one of these is talking about cosine? Hopefully you said D because A is right here starting at the middle. So this is a sine of x, 3 sine of x to be exact. And this right here will be 3 cosine of x. Okay. So our answer was D. For this one, now we're going to use what we learned and we're going to try to match these. So for question 1, sine of x, what function matches sine of x? Okay. Hopefully you said this one right here, right? It starts at the middle, then goes to the max, then back to the middle, then to the minimum, and to the max. So 1 is C. Okay, this is number 1. Okay, let's try the next one. Cosine of x. We just did this one. Which one of these reminds you of cosine of x? Okay, so hopefully you saw that this one is associated to A because it starts in the max, then to the middle, then to the minimum, and back up. Okay. Okay. Here's where it gets a little bit tricky. Let's go with our negative sine of x. When we have a negative in front of our function, that means it's a reflection about the x-axis, meaning if something was in its max, in its reflection wave, this would have been, we agreed that this one was cosine originally, but if it was negative cosine, now it would be at a minimum instead of at its max. And everything else would go ahead and follow. Everything would be reflected about the x-axis. So let's go ahead and find negative sine of x. Would it be B or D? Hopefully you said B, because sine starts at the midline, then everything got reflected. So this one right here is 3. So you can pretty much see how this is sine of x and this is negative sine of x. Notice how everything from sine of x, everything in this function was reflected to create this function right here. Okay. Last but not least, what do you think negative cosine will be? Hopefully you saw and you compared that these right here with our function. Let me go ahead and get blue. This is cosine right here. This is our max. If I go ahead and reflect it, it should drop to the middle, to the bottom, sorry, and it gives us this point. Same thing goes. If I am at right at the middle, back at cosine, right over here, and I reflect it, it should go back to its max. So this is the. I really hope this has helped, guys. If it did, or if it didn't, guys, please let me know. But if you do have questions, please reach out to me. I'll gladly try our best to help you out in the office hours. Remember, they're at 2:30 every single day, and our midterm will be on Wednesday. Thank you, bye. Thank you, guys, and goodbye.